Hi, welcome again, and welcome back to the channel. Let's start O-Levels, Chemistry Paper 2, October-November 2025, Variance 22. Choose from the following compounds to answer the question. So this compound is methanol. This compound is methanoic acid. This is ethanol. This is ester, methyl ethanoate. This is cyclobutane. We have done this structure in class. This is butane, this is butanene, and this is butanoic acid. All right. Each compound used once, more than once, not at all. State which compound is methanoic acid. Obviously, compound B is methanoic acid. Next is manufactured by hydration of ethene. When hydration means addition of water. Or addition of steam. So when we add steam into ethene, it will turn to ethanol. And from this, ethanol is basically compound C. Has an empirical formula C2H4O. 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 1, 2, 3, 4. C2H4O. Okay. So first of all, take out the molecular formula of compound H. We have 4 carbon atoms. In this 3 plus 2, 5, 5 plus 2, 7, 7 plus 1, 8. 8 hydrogen atoms and 2 oxygen atom. When we halve this, or when we halve the molecular formula, you will get the empirical formula. So it's going to be C2H4O. So examiner is looking for the exact empirical formula. So compound H gives you the empirical formula. Okay. Is used to make an addition polymer. Remember always, addition polymer is always formed when alkene monomer undergoes addition polymerization. So alkene forms addition polymer. So when alkene forms addition polymer, so technically compound is used to make an addition polymer. Compound G, because it is an alkene, it undergoes addition polymerization to give a addition polymer. Okay, so compound G is the right answer. Is an ester. So ester is basically this methyl ethanoate. Compound D. Next, state 2 compounds are structural isomers of one another. That's very easy. By the way, this is butanene, which has a molecular formula of C4H8. This is cyclobutane, which has a molecular formula of C4H8. So both compounds have the same molecular formula, but different structural formula, which is why both of them are structural isomers of each other, or generally speaking, isomers of each other. Why they are isomers? Because it doesn't have any functional group. It does have a functional group of double bond, right? So what you can write here is E and G. All right, that's the end of first question. Let's move on to the next one. A sample of titanium found an asteroid contains 4 isotopes. Table shows the percentage abundances of these 4 isotopes. Describe one difference between the isotopes. This. See, guys, both the isotopes have same atomic number but different mass number. So when we talk about difference, either we can write different mass number or we can write different number of neutrons. Both are acceptable for the examiner. Okay. So I'm going to write different number of neutrons. Okay, you can write different mass number also. Okay, explain why all the isotopes of titanium have the same chemical properties, because they have same atomic number, so they have same number of electrons, and chemical properties depends on number of electrons. So if number of electrons are same, chemical properties are also same. So we can write they have same number of electrons, and also they have same chemical properties. We can write this answer in that way also, that since they have same number of electrons, so they will have same electronic configuration, which is why they will have the same chemical properties. It doesn't make any difference if you write that sort of explanation also. Okay, both of them are acceptable. Show by calculation that the relative atomic mass of titanium for this sample is this. So I need to apply the formula: mass of first isotope, which is 46, into abundance of first isotope, which is 9, plus mass of second isotope, 47, into abundance of second isotope, 7, plus mass of third isotope, 48, into abundance of third isotope, 75, plus mass of fourth isotope is 49, into abundance of fourth isotope is 9, divided by total abundance. So we need to add these values. So 75 plus 9 plus 9 plus 7. So it's basically 100. So we need to divide by 100. Okay. So it's 46 into 9 plus 47 into 7 plus 48 into 75 plus 49 into 9 is basically 47.84. Oh, sorry, 4784 divided by 100. So it's basically 47.84. Okay. So that's the second question. Let's move on to the third one. The equation for the reaction between aluminum and dilute hydrochloric acid is shown. Shows the reaction pathway diagram for this reaction. Since energy of product is lower than the energy of reactant, which means this reaction is exothermic. All right. So technically, this A belongs to activation energy for exothermic reaction, and activation energy is represented by A. And since the arrow is downward, which means this arrow represents enthalpy change. And for all exothermic reaction, the enthalpy change is basically negative, which is why the arrow is downwards. Identify the energy changes labeling A. तो A जो है वो एक्टिवेशन एनर्जी, और B जो है वो एंथैल्पी चेंज. Next is use reaction pathway diagram to explain why the reaction is exothermic. Because energy of product is lower than that of reactant, Also, enthalpy change arrow is downwards. Describe a chemical test for hydrogen. Test. Use a burning splinter. Observation if hydrogen present. Burns with a pop sound. Okay. Let's move on to the next part of the question. A sample of aluminum reacts completely with dilute hydrochloric acid. This equation is already given, so I'm going to use this equation for the calculation. Okay. A total volume of 366 cm cube of hydrogen measured at RTP is produced. That indicates that I'm going to calculate the number of moles of hydrogen in the first place. So that's my first step. Moles of hydrogen. 366 divided by 24,000 cm cube. Oh, 366 divided by 24,000. It's basically 0.01525 moles. Okay. Examiner is looking for the for the mass of sample of aluminum, which means first I need to find out the mole of aluminum, and for that I'm gonna use molar ratio from the equation. So aluminum has 2 moles and hydrogen has 3 moles. So molar ratio between aluminum and hydrogen is 2:3. When we have 0.01525 moles, moles of aluminum would be 0.01016 moles. So basically it's 0.0166 moles. Okay. We know the AR of aluminum, which is 27. I'll get the MR from periodic table. So using that mass, so moles of aluminum is 0.010166 into AR of aluminum is 27. So mass of aluminum 0.2745 moles. All right. Examiner is looking for 2 significant figures answer. So basically it's 0.27 gram. Okay. So that's the end of third question. Let's move on to the fourth one. Chlorine, bromine, and iodine are elements in group 7. These elements are also called halogens. Fluorine has a low boiling point. It is gas at room temperature. Describe the arrangement and motion of molecule in fluorine gas. Gaseous molecules are very far away from each other. So they move. And also, highly irregular arrangement of atoms exist So they move randomly. Okay. Explain why fluorine is a gas at room temperature. Use idea about the structure and bonding. Because it exhibits weak van der Waals forces and weak van der Waals forces also called intermolecular forces. Okay, so you can write intermolecular forces also instead of van der Waals forces, but since you are in 11th grade now, so I believe you need to use van der Waals forces instead of intermolecular forces. Bromine reacts with lithium to make ionic compounds. Lithium bromide suggests two physical properties of lithium bromide. Since lithium bromide is an ionic compound, so all ionic compounds are solid at RTP, soluble in water, high melting and boiling point. And also they conduct electricity in aqueous medium or in molten state. So by the way, examiner is looking for the physical properties. So I have written three, so you can write any two from them. Okay. Construct an ionic equation to show the formation of lithium ions from lithium atom. So this is lithium atom. Lithium belongs to group 1 of the periodic table, which is why it loses one electron from its valence shell and will turn to lithium ion, an electron, or you can write one electron. Okay. Construct ionic half equation to show the formation of bromide ions from bromine molecule. So it is bromine molecule. Bromine always exists in diatomic state. It will gain electron and convert it into bromide ion. Since we have two atoms here, so we need to put two here to balance the equation, and which is why we need to put two here also. Okay. Chlorine gas is bubbled into aqueous lithium bromide. A reaction takes place. Name the two products of this reaction. Let me write the equation first. This is lithium bromide. It is reacting with chlorine, converting into bromine and lithium chloride. Okay. By the way, how many bromine atoms here? Two. So we need to put two here. And since we have two lithium and two chlorine, so I'm gonna write two here. So bromine and lithium chloride would be the two products. And examiner is looking for the name. So it's basically bromine and lithium chloride. Okay. So that's the end of fourth question. Let's move on to the fifth one. Nickel is a transition element. One of the properties of nickel is that it is a catalyst. State a reaction that uses nickel as a catalyst. Hydrogenation of alkene. So reaction of ethene with hydrogen is also called hydrogenation. State one other chemical property of nickel is a typical of transition element. Uh, Nickel shows variable oxidation state. And also you can write it forms a colored compounds. Okay. The physical properties of nickel and its alloys can be explained using idea about structure and bonding. Explain why nickel is malleable. Because the layers of atoms can slide over each other. In a lattice, बल्कि इस तरह से लिख लें, in a positively charged lattice. Okay. Nickel and other elements are added to iron to make the alloy stainless steel. Explain why stainless steel is harder than either pure nickel or pure iron. Include label diagram in your answer. Okay. So first of all, this is the structure of an alloy, and this alloy has different size of atoms. All right. Now from this, in alloy, mixture of metals have different sizes. Alloy mixture of metals have different sizes of atoms, which is why these atoms cannot slide over each other. And therefore, stainless steel is harder than pure nickel or pure iron. Stainless steel is used to make cutlery because it is hard and strong. State one other property that makes stainless steel suitable to make cutlery. Stainless steel is corrosion resistant. It is resistant to corrosion. ये rust resistant alloy भी तो होता है ना? It is resistant to corrosion or rusting. Compound X contain nickel, hydrogen, and oxygen only. X contain 2.2% by mass of hydrogen and 34% by mass of oxygen. Calculate the empirical formula of compound X. Okay, so first of all, we have nickel, hydrogen, and oxygen. So hydrogen is 2.2%, oxygen is 34.5% oxygen. So 35.4, 34.5 plus 2.2. So when we subtract 100 from this value, I'm going to get 63.3. So what I've done here is I need to add these two values, and the overall value from these two subtract from 100. All right. So I'm going to get 63.3 gram of nickel by percentage. Okay. So that's the working behind this value. Now nickel, okay, let's go nickel is 59. Okay, nickel is 59. So let me divide by 59. Let me divide by 1. And it needs to divide by 16. Divide by 59. You will get 1.072, which is 2.2, and 34.5 divided by 16. 1.531. तो ये हो जाएगा 1.072, 1.072, 1.072. So to get the simplest ratio, we need to divide the lowest value from all of them. Okay, it's going to be 1. So 2.2 divided by answer, it's going to be 1.43. Oh, I bad. 2.2 divided by 1.072. That's 2. 1.531 divided by 1.072 is going to be 1.42. Hold on, 1.531. But 4.5 divided by 16. Oh my bad. What I've done here, that's not a correct value. It's 2.156 divided by 1.072. So it's going to be 2. Okay. So the empirical formula is going to be nickel H2O2. Okay. The equation for the reversible reaction between carbon monoxide and nickel is shown. The forward reaction is exothermic, which means the delta H needs to be negative. The reversible reaction is allowed to reach equilibrium in a closed system. Predict and explain the effect of increasing the pressure on the position of equilibrium. Increasing the pressure on the position of equilibrium. So first of all, I'm going to ignore this because it is solid. Okay. Take out the moles on the reactant side, which is 4. Take out the moles on the product side, which is 1. So when you increase the pressure, equilibrium favors towards right hand side because of less number of moles. Okay. So prediction. Equilibrium favors towards right hand side. Now the explanation is basically easy. Reactants has more moles of gases, while product has less number of moles of gases. All right. Let's move on to the next question. This question is about the covalent compound hydrogen peroxide. By the way, hydrogen peroxide is a covalent compound. It exhibits covalent bonding. It has a displayed structure like this. Draw the dot and cross diagram to show the electronic arrangement in a molecule of hydrogen peroxide. Only draw outer shell electrons of oxygen and hydrogen. Okay, so that's an easy thing. This is oxygen atom. This is another oxygen atom. And this is hydrogen atom. And this is another hydrogen atom. Okay, this is oxygen atom. This is oxygen atom. This is hydrogen atom. And this is hydrogen atom. Now oxygen has 6 valence electrons. And single bond exists between the between oxygen atoms, which means one electron of each element shared together. So this is 1, 2, 3, 4, 5, 6. For this oxygen, 1, 2, 3, 4, 5, and this one is 6. Hydrogen electron is represented by cross. So that is going to be your dot and cross diagram, okay? A sample of hydrogen peroxide has a mass of this, which means, first of all, I need to get the MR of hydrogen peroxide. So MR of hydrogen peroxide is easy. 16 times 2 plus 1 times 2, it becomes 34. Okay. Calculate the number of molecules of hydrogen peroxide in this sample. So first of all, take out the number of moles of hydrogen peroxide. So it's basically 0.170 divided by 34. So 0.170 divided by 34 is basically 5 into 10 to the power minus 3. Okay. So in order to calculate the number of molecules, I'm going to use Avogadro constant, and Avogadro constant means 1 mole has this much molecules. I'm going to use this relationship. If 1 mole is always equals to 6.02 times 10 to the power 23 molecules. When we have 5 into 10 to the power minus 3 moles, the molecules is going to be 3.01 into 10 to the power 21 molecules. Calculate the total number of atoms in this sample of hydrogen peroxide. Okay. So we know the moles of H2O2. Guys, in H2O2, we have 2 hydrogen atoms and 2 oxygen atoms. Okay. So this must have 1 mole, and in total it has 4 moles of atoms. When we have 5 into 10 to the power minus 3 moles of hydrogen peroxide, how many moles of atoms in there? So it's basically 5 exponent minus 3 into 4. It's going to be 0.02 moles of atoms. All right. So 1 mole is always equals to 6.02 times 10 to the power 23 atoms. And when we have 0.02 moles, so atoms would be 1.204 into 10 to the power 22 atoms. Okay, I hope it makes sense to you. Let's move on to the next page of this paper. When aqueous hydrogen peroxide reacts with acidified aqueous potassium magnate 7, by the way, in this reaction, H2O2 is acting as a reducing agent. And aqueous potassium magnate 7 is basically an oxidizing agent. Okay. Which is why color changes from purple to colorless. Okay, that's a very important, significant sort of observation in this reaction. When aqueous hydrogen peroxide reacts with aqueous potassium iodide, there is a color change from colorless to brown. Now, in this reaction, hydrogen peroxide is acting as an oxidizing agent, because potassium iodide is acting as a reducing agent. And we have done this whole scenario in the class also, okay? If you remember. So hydrogen peroxide acting as an oxidizing agent, acting as a reducing agent. When it is treated with potassium magnate 7, it will act as a reducing agent. When it is treated with potassium iodide, acting as an oxidizing agent, which is why color changes from colorless to brown. All right. Explain what these observations indicate about the chemical properties of aqueous hydrogen peroxide. That's very easy. Reacting with aqueous potassium magnate 7, it is acting as a reducing agent while reacting with potassium iodide. It is acting as a it is acting as an oxidizing agent. Okay. Barium peroxide, that's very tricky. Barium peroxide is basically BaO2. All right. This is barium peroxide. Reacts with cold dilute sulfuric acid to produce hydrogen peroxide. Let me give you the equation. This is barium peroxide. It is reacting with sulfuric acid, converting into barium sulfate and H2O2. Okay. And barium sulfate has a white precipitates. Deduce the formula of barium peroxide. Since barium ion and peroxide ion has same charges, so these charges will cancel out with each other, and so the formula is going to be this. Okay. The equation for the decomposition of hydrogen peroxide is shown. The rate of decomposition increases as temperature of the aqueous hydrogen peroxide increases. Explain why. Uh, as temperature increases, kinetic energy of molecules increases. If kinetic energy of molecules increases, then molecules move faster, and so collision frequency increases, and hence rate of decomposition of hydrogen peroxide increases. Okay. Manganese 4 oxide is a catalyst for the decomposition of hydrogen peroxide. We have done this experiment in the class in chemical kinetics chapter. All right. Describe how a catalyst increases the rate of reaction. Catalyst provides an alternative path which reduces the activation energy. Okay. Let's move on to the next question. Oh, PET is a polyester and it is a condensation polymer. This is dicarboxylic acid. This is diol. That's what we have done in the class. One box is shaded, another box is unshaded. This shaded box and unshaded box represents hydrocarbon chain. Obviously, these different boxes represents different hydrocarbon chain. Okay, one shaded, one unshaded, which means hydrocarbon chains are different in both the boxes. All right. Name two types of monomers shown in this. The first one is dicarboxylic acid. Since we have two COH group, which is why it is called dicarboxylic acid, we have two OH group, which is why it is also called diol. Okay. The two monomer to react polymer and a small molecule. Name the small molecule. When carboxylic acid and alcohol react together, always a water is formed, which is a small molecule. Draw the structure of PET. Your structure should show two repeating units. Oh my goodness. Okay. Two repeating units. Okay. This is COOH. Okay, this is dicarboxylic acid. Plus this is diol. Then again dicarboxylic acid. And this is diol. Okay. तो ये भी पॉजिटिव, ये भी पॉजिटिव, ये भी पॉजिटिव. तो यहां से क्या बनेगा OH, यहां से क्या बनेगा H, दोनों मिलकर बनाएंगे वाटर. OH and H combine together to give water. OH and H combine together to give water. So I'm gonna get n moles of water from here. Okay. Plus obviously H is removed from here and OH is removed from there, which means the structure is going to be like this. So आपको बहुत समझदारी से जो है ना एटम्स का अरेंजमेंट करना है, बॉन्डिंग दिखानी है, जैसे मैं दिखा रहा हूँ. Okay. So two repeating units. Technically, this one is the first repeating unit, and this one is the second repeating unit. Okay. So these are the two repeating units. I hope it makes sense to you. State two, environmental. So I need to write this structure, by the way. Examiner is looking for this structure. Okay. State two, environmental challenges caused by disposal of plastic made of PET. Environmental challenges. When this compound is burnt, obviously toxic gases are removed. When plastic made of PET burnt, it releases toxic gases. Second, we need to dump these sort of plastics on the landfill sites. Dumped at landfill sites. Which is expensive land. Name one condensation polymer that is polyamide, nylon. Even you can write protein, but nylon is perfect. Okay. You can write protein also. That's the end of this question. Question number 7. Let's move on to the question number 8. Figure shows the displayed formula of an unsaturated carboxylic acid. Displayed formula means show all the atoms and all the bonds. And unsaturated means double bond between the carbon atom along with the carboxylic group. Explain why X is unsaturated. Because of double bond exist between carbon atoms. Describe the observation when X reacts with aqueous bromine. So obviously it's going to be red brown, also called orange to colorless. And that's what I've given you. Same sort of observation in the class. Okay. X is a weak acid. All carboxylic acids are weak acids. We know that. Describe the meaning of the term weak acid in weak and weak acid. Weak means partially ionizes in aqueous medium. Okay. X reacts with sodium carbonate. Name the gas forms in this reaction. Whenever any carboxylic acid react with any sodium carbonate or carbonate, always carbon dioxide gas is given off. And examiner is looking for the name. So I'm not going to write the formula, okay? This is carbon dioxide. If you remember, we have done this reaction in the class, right? Describe how an ester is prepared from X. When this X containing carboxylic acid when this X containing carboxylic acid reacts with alcohol, then ester is formed using heat and concentrated sulfuric acid acting as a catalyst. Okay. Next, ethanoic acid is a saturated carboxylic acid. Ethanoic acid is made from ethanol. So ethanol needs to oxidize in the presence of potassium manganate 7. Use acidified solution of potassium manganate 7. Instead of writing this, you can also write bacterial oxidation. Dilute ethanoic acid reacts with aqueous sodium hydroxide. Name two products of this reaction. When ethanoic acid is basically an acid, reacts with alkali, then salt and water is formed. So salt is going to be sodium ethanoate. And water. Okay. Let's move on to the next question. Hydrated zinc chloride is a white solid. State the meaning of the term hydrated. Hydrated means combined with water chemically. Okay. Aqueous ammonia is added dropwise until in excess to small volume of aqueous zinc chloride. Describe the observation during this reaction. Well, ammonia is not going to react with chloride ions, but ammonia definitely react with zinc ions, forming white precipitates. White precipitates are formed with few drops in excess. Aqueous ammonia, white precipitates are soluble to give a colorless solution. Okay. Describe the observation when aqueous silver nitrate is added to aqueous zinc chloride. Well, this silver ions reacts with chloride ions, and as a result, you will get white precipitates of silver chloride. So I'm going to write white precipitates. And we can write the equation. See, this is zinc chloride. It is reacting with silver nitrate, converting into silver chloride and zinc nitrate. Okay. Dilute and concentrated aqueous zinc chloride are electrolyzed separately using carbon electrodes. Carbon is basically the graphite electrode. So dilute in aqueous dilute zinc chloride, product at anode, oxygen gas, obviously. When we talk about concentrated aqueous zinc chloride, obviously chlorine is given off at anode because chloride ion has higher concentration, so they will discharge first from the electrolyte. And obviously in this hydrogen gas, okay, so examiner is looking for the product. So oxygen and water, I think we need to write both because examiner is not looking for the observation, is looking for the product. The oxygen and water, that's very, very important, okay? But examiner is also saying product. So when we talk about product, which means we need to give specific. So I think I'm gonna go for oxygen. Okay. Explain why aqueous zinc chloride conducts electricity. Aqueous zinc chloride conducts electricity because of the presence of free mobile ions. In solid, they cannot conduct due to the absence of free mobile ions. Okay. Let's move on to the last question. Water is an important part of the environment. Rivers and lakes are natural sources of water. Name one substance in river water that may be harmful. Explain why this substance may be harmful. So, substance is heavy metal ions, plastic, harmful microbes, nitrates and phosphates. So, I'm going to go with nitrates and phosphates. So, this part has multiple answer. So, nitrate and phosphates are more easier. Explanation. These causes eutrophication, and eutrophication means deficiency of oxygen in water. Okay. Name one substance in river water that is beneficial. Explain why this substance is beneficial. Dissolve oxygen. Mm, useful for aquatic life and underwater plants. Describe three processes involved in the treatment of water for domestic water supply. State the reason why each process is used. The process one is sedimentation. To remove insoluble solids. Okay. Process 2, addition of carbon or charcoal. To remove taste and odor. To remove bad taste and odor. Process 3, chlorination. To remove germs and bacteria. Or to remove microbes can also be the correct option. Okay. All right. Next, describe a qualitative chemical test to show the presence of water. Well, you can use anhydrous cobalt-2-chloride or anhydrous copper-2-sulfate. So I'm going to go for anhydrous copper-2-sulfate. By the way, anhydrous copper-2-sulfate is a white solid. When it mixes with water, blue solution is formed. Explain how the purity of water is tested by measuring its boiling point. It boils at a fixed temperature. All right. So that's the end of this question. Let's move on to the next one. Oh, that's the end of this paper, guys.